life. As of yet, there is only one example we know of, the life we find here on Earth. There is no definitive proof of life anywhere else in the universe. But that does not mean for certain that it's not out there. If there is alien life on planets other than our own, what might they look like? What would be their biology, and what would we see of their civilization? You might think there is no way to predict this. However, believe it or not, even though we have never seen a single alien, we can make educated guesses based in science to help us know what to expect. And it's all thanks to a simple principle: form follows function. I'm Alex McColgan and you're watching Astrum. And although we cannot say with exact certainty what any aliens visiting us might appear like, or how they behave culturally and technologically, today I'm going to share with you some ideas that might mean, if they ever do land on our doorstep, you aren't completely caught off guard. But first, let's talk about why we look the way we do. As you look down at your own body, even if you do not know what all of it does, you are an incredible example of optimization. You likely have 2 hands complete with fingers and opposable thumbs, ideal for grasping tools and performing fiddly, delicate operations. You have a digestive system that is capable of taking in matter, extracting nutrients, and using them to build up or repair yourself. You have legs for locomotion, a brain for thinking, a heart that will, on average, pump 2.5 billion times across your lifetime without breaking. All of these parts of your body perform specific functions and have been honed over millennia to be really good at what they do, even if you don't feel it sometimes. You are an example of form following function. Thanks to natural selection and random mutation, nature is really good at figuring out what works. When Charles Darwin was voyaging through the Galapagos Islands, he noticed that different finches had different shaped beaks. After observing them for a time, Darwin noticed that the finches with larger, more heavy-set beaks ate different types of food than finches with smaller, daintier beaks. In fact, a large beak was ideally suited to breaking open tough seeds or nuts, while the smaller beaks were more suited to getting in nooks and crannies for grabbing insects. This observation was the basis for his well-known theory of evolution. In this theory, thanks to genetic variation and competition, nature is constantly trying out new things to see what works. And there are certain things that give you an edge. Thanks to all the light that was bouncing around from our sun, organisms that evolved to take advantage of this by developing sight had a bigger advantage over organisms that did not. They could find food better, or avoid predators, or generally navigate their environment. So useful is sight that nature did not just come up with it once. We believe the eye evolved independently about 40 times over the course of life on Earth. 40 different species that previously could not see evolved eyes. This is called convergent evolution, and eyes are not the only example of it happening. Bats are not related to birds, and yet both developed wings to fly. And speaking of bats, both bats and dolphins independently evolved echolocation to help them see in environments where light was not so plentiful. Photosynthesis has arisen dozens of times. Koalas have almost identical fingerprints to humans. This happens because there are some selective pressures that are simply universal. Everything that lives needs to gain nutrients, grow, and reproduce. And as a result, like a plant bending its roots around rocks to find softer soil, nature is good at figuring out the best way of getting what it needs. Because of the prevalence of light, eyes are just a good idea. And when something works, nature sometimes comes up with it more than once. This means that on planets that are similar to our own, it's entirely possible that evolution would end up going a similar way. Although hypothetical aliens on other planets might not look exactly like us, they might look surprisingly similar. I always thought that it looked silly that so many aliens in sci-fi films were humanoid, but perhaps this is more than just a way of easing pressure on the film's costume department. Convergent evolution says this might actually happen. If it worked for us, maybe it just works generally. Any alien that made it to the stars would need to have the ability to work tools. So, fingers or something similar would be a likely addition to an alien race. Large heads filled with complex brains for analysis and problem solving would also be a benefit. The human brain is the most complex of any animals on Earth, with 86 billion neurons. It's not so unreasonable that aliens would be the same. Thanks to our brains, it became less important to keep ourselves warm with fur, as we could craft clothes for ourselves, so aliens may not be hairy or thick-skinned if they are intelligent. Of course, this kind of logic might not carry all the way, because life might not arise on a planet that's exactly the same as ours. If there are different selective pressures, different adaptations might occur. For instance, on a planet with low gravity, plants and animals would be able to grow much taller than on Earth. There would be less energy costs to lifting nutrients up through their bodies or pumping blood around if aliens use those kind of systems. While conversely, on a planet with very high gravity, you'd likely see stockier, shorter, heavier built aliens. Their bones would need to be denser to support them in heavier gravity. Or possibly they would be aquatic, as gravity is less of a problem in water. On a planet that is further out from its star than ours, there would be less light, so an alien's eyes might be bigger. Or maybe aliens on such planets would rely on things like echolocation to see what is around them. On planets with elliptical orbits, seasonal temperatures would vary much more wildly. Perhaps on such planets you'd see an increase in the ability to hibernate, or even come back from near death, such as tardigrades, and their incredible ability to return to animation after being in the harshest of environments like the depths of space. Temperature can also affect size, such as in the depths of our oceans there occurs deep sea gigantism, as large bodies can more efficiently be kept warm, while in deserts, small animals have a larger mass to surface area ratio, allowing them to disperse heat more effectively. On a planet with fewer magnetic fields, more bombarded by cosmic radiation, perhaps life would have shorter lifespans, in much the same way as around the heavily irradiated Chernobyl nuclear power plant. Dogs and other short-lived organisms thrive, while longer-lived humans suffer. In each case, form follows function. Life will adapt to suit the conditions it finds itself in. And it doesn't end there. Did you know that this logic can apply to cultures and civilizations too? When the Spanish conquistadors met the Aztecs, there was a significant technological gap, in spite of both groups being humans. Some historians hypothesize that this can be linked to things like the ease at which each group could farm. Intensive crops that require a lot of effort to grow require more of the population to spend their time farming, leaving fewer individuals free for invention and scientific pursuits. There are likely many other factors at play too, but environment is certainly one of them. Prevalence of coal or other fuel sources could spark an industrial revolution. The presence or absence of silicon or rare metals might help or hinder a computer revolution, speeding up or slowing down a civilization's progress. Once an alien race has evolved to the point where it has become intelligent, unless it came into being through some weird mechanism we don't understand, it probably did so through outcompeting its rivals and collecting resources for itself and its offspring. Civilizations made up of such creatures will most likely also have a hunger for space and resources. Whether they gain these things through clever diplomacy or aggression, it is most likely that they will want them. Form follows function. This quest for expansion and seeking more and more energy and resources led Soviet astrophysicist Nikolai Kardashev in 1964 to propose the Kardashev scale for classifying the different kinds of alien civilizations that might exist out there. He grouped civilizations into 3 kinds. Type 1 civilizations can completely utilize the energy available on their planet. We have not quite reached this point as a species, so we are roughly a 0.7 on Kardashev's scale. Type 2 completely utilize the energy available from their star, possibly by building a giant megastructure such as a Dyson sphere to capture and utilize all of its energy output. Type 3 civilizations would be able to utilize the entire energy output of its galaxy. We have seen no evidence of an alien civilization such as this one, which is for the best, as they would likely see us in the same way we see bacteria. Mildly interesting, but otherwise completely beneath their notice. Other scientists since Kardashev have proposed further additions to this scale. Type 4s that use all the energy in the universe. Type 5s that use all the energy in multiple universes, or even the enigmatic Type Omega, capable of utilizing energy sources beyond even that, perhaps existing outside of time entirely. Such a civilization would essentially be gods. We would have no way of detecting them, because nothing in the universe would exist except in the way they wanted it to, and we would have nothing to compare their existence against. While this may seem like a bleak outlook for humanity, if we ever came across another alien race, under this theory we would almost certainly end up competing for resources in one way or another, or just getting steamrolled by a vastly higher power. There are actually other possibilities for alien development too. After all, not all humans are interested in expanding ever outwards. In fact, with the advent of internet and online cyberspace, more and more human interaction is taking place in virtual spaces. Carl Sagan proposed a model that classifies alien races based on how many unique pieces of information they collectively know. Although much harder for us to detect at a distance, and admittedly hard to measure, this way of gauging advancement does not require an alien race to infinitely expand. An intelligent race that started looking internally, or even one that spent its entire conscious time in some kind of cyberspace, could still learn more and more about itself and the universe as a whole, while taking less and less space within that universe. For the record, Carl Sagan's scale is alphabetic, where we were at about a Type J civilization, as apparently we knew 10 to the power 13 bits of unique information in 1973. While I haven't been able to find out exactly how he worked out that figure, and mention in the comments if you know, we are probably further along this scale now, 50 years on. But as a comparison, a Type Z civilization would need to know 10 to the power 31 bits, more information than exists in the whole universe, so it's unlikely that such a race exists, at least not yet. Ultimately, we do not know for sure. Alien life continues to remain elusive, and while it's true that we have not met an alien civilization, it is comforting to know that it's entirely plausible there would be something about them that we could understand or even find relatable. Form follows function. We as humans are the beings that think and gain mastery of our world. Perhaps one day we will meet another race that does the same things we do. Rather than seeing something truly alien, it perhaps will be like looking into a mirror. I'll leave it to you to decide whether that is a comforting thought or not.